Hi, my name is Camilla. I am the Engagement Officer for the On-Farm Carbon Advice team. Today, we have our last webinar of 2025, Turning Weeds into Biochar with Fabiano Jimenez. Now, before I begin, I would like to acknowledge the traditional custodians of the lands and waters in which we gather today. I'm on Wiradjuri country based in Orange and recognise their continuing connection to the land, water, and community. We pay our respects to elders past, present, and emerging, and extend that respect to all Indigenous peoples here today. So today's session will be recorded and will be made available on our website. There will be an opportunity for questions at the end of the presentation, but please feel free to put any questions in the chat. Okay, and so let's get started. So, Dr. Fabiano Jimenez is a senior research scientist with the DPIRD's Forest Science Unit. His research focuses on wood products, biomass, bioenergy, and carbon. Fabiano, over to you.
Thank you, Camilla, and thanks for the invite to talk today, and good afternoon, everyone. As Camilla said, I'm Fabiano Jimenez. I'm part of the Forest Science Unit from DPIRD, and today I'll be talking about some work we've been doing recently around the development of a mobile biochar unit, which we envisage will be useful for processing weeds and other biomass of interest. So in terms of a quick outline for the talk, firstly, we sort of talk a little bit about the different biomass options that may be available for New South Wales, and then what is the biochar opportunity in terms of production, in terms of the conversion of the biomass into biochar. Then some of the developmental work around the mobile biochar unit and where we're up to with that, and then what we envisage the opportunity might be for New South Wales. Now, in terms of biomass in Australia and in New South Wales, there are a range of different opportunities there in terms of biomass types that may be suitable for this conversion. So firstly, we talk about residues from a number of different industries, particularly primary industries, agriculture, forestry primarily, and also landfill waste. Noxious weeds, things like lantana, blackberry, invasive native species, particularly out western parts of New South Wales. Also talking about wattle or acacias that grow after large bushfires. And then also the opportunity for growing short rotation woody crops in marginal, less productive land. So that just gives you a bit of a picture of what we're talking about when we talk about biomass types in Australia. And particularly for New South Wales, we've been working in this space for quite a while now. And back in 2016, we started a project. So we led the New South Wales component of what was called the Australian Biomass for Bioenergy Assessment program. And that particular project was all about mapping existing biomass sources for Australia. So we had a task to do that work for New South Wales. And we continue to keep that data up to date until now. So the idea is to really sort of get a good understanding about where the biomass is in the landscape and how feasible it may be to access it. So that work was translated into a series of maps or in a spatial platform, which is available publicly. And we've got some of that information on our website as well. So if you go to this address at the bottom of your screen here, you go to the New South Wales specific data. And in this slide, you can see a summary table that tells you, gives you an idea of the quantum of biomass that may be available after harvest of various different crops in New South Wales or associated with livestock and other things. So conservatively, we assume that there is over 20 million tons of that resource available each year, which is currently not utilized for any particular purpose and which could be sustainably extracted. So we drill down into the detail of some of those tables, and you can see here for cropping, for instance, it's divided up between cereal straw, non-cereal straw, hay and silage, and then the various different types of crops that fall under the category and the volumes of product or residue that may be available following the harvest of those crops. So we've taken that information one step further, and we built another tool called the New South Wales Biosmart, or Spatial and Modular Assessment of Resources tool. And the idea with that tool was to basically take the information that we've developed under that ABBA program and provide an analytical capability to basically interrogate that information in the context of New South Wales, and to allow the user to draw a shape anywhere in New South Wales. Could be a circle, polygon, or whatever it may be. And the tool automatically estimates how much biomass that region may contain. And there's a bunch of other different layers and capabilities within the tool as well that sort of intersect the information with things like soil type, rainfall, etc., etc. And the other thing you can do as well is you can sort of have a pretty good idea for if you select one particular cropping type, for instance, in this case, wheat. You can see here there is a heat map for New South Wales, which tells you where in New South Wales there is and there are larger volumes of that resource potentially available. And then you can develop transport routes and conversion opportunities, etc., etc. So I would encourage you to go and have a look at it if you're interested, and that's the website link at the back of the screen. And just some of the examples of some of the outputs of the tool. And here, using Tamworth as an example, here drawing a circle around it of 100 Ks, and then how much biomass of different types of residues may be available for that particular region of the state. As I said, it's just a little snapshot of what it can do. There's many other capabilities there, and I encourage you to have a look at it. The other opportunity that we've been working on for quite a while now is around planting short rotation native woody crops in marginal, less productive land. We have a network of trials that we've been monitoring now for over 6 years in New South Wales. We've got about over 60,000 trees that we planted, and that we've been monitoring management of those crops in a short rotation basis, and then monitoring the performance of the coppice material after the trees are harvested. So the idea is to understand the potential for, as I said, less productive land to be used for that purpose. And one of the attractions there is that you're not just providing fiber for any number of different opportunities, including biochar, but also you're sort of using the trees as a way of helping improve the environmental credentials of the land. So in terms of carbon sequestration, in terms of land rehabilitation, improving water quality, prevention of soil erosion, etc., etc. So you can sort of look at the trees as a way of managing the tool at the same time as providing a new market for the landholder. So that's just another opportunity for biomass production. Another one which is geographically constrained, which is probably more around the western parts of New South Wales, around invasive native species. There are large areas of the state which contain that sort of biomass. We're talking about millions of hectares, really. And currently, as we know, a lot of farmers and landholders go through cycles of clearing and then regrowth for grazing, and then clearing again. And typically the biomass is burnt or left to decay on site. So potentially there's an opportunity there to do something else that will provide a more useful outcome for the biomass. Weeds, as we know, it's a massive problem in New South Wales. There's many different types, but blackberry is one of the key ones. It's found to be one of the most widespread problematic weed of national significance for New South Wales land managers. Infects nearly 10 million hectares of land in Australia, so it's quite a large problem. One of the issues we have, which from a forestry background, people have noticed, and studies have been done to show that if you chemically treat blackberry, obviously you're going to kill the plant, and it's going to become dry, and then it becomes an increased problem in the event of a fire. So it adds other issues as well in terms of the different management possibilities that you have, and the unwanted, I guess, flow-on impacts of some of those treatments as well. So it's quite a difficult challenge in terms of managing from a number of perspectives, and even if there was a market for it, you could not harvest and transport it as is because of you're not allowed to, because you don't want to be spreading weeds across the landscape. Similarly for Lantana, it's quite a widespread problem, but really more sort of in those coastal areas of New South Wales, or closer to the coast, really. It's about 4 million hectares or so in Australia that impacts on. It costs a lot to manage, over $20 million a year for landholders. It has other issues as well for humans and livestock in terms of it being poisonous, so it creates extra issues. And just like any other weeds, it cannot be harvested and transported for processing off site. So if you're going to do anything with it, you have to do it on site. Other interesting consideration here, particularly as climate change becomes more and more of an issue, is the impact of that on bushfires and then the regeneration that happens post bushfires. And typically what we have is following a bushfire where large areas of forest are destroyed. You've got the initial sort of point of regeneration where the shrubs and grasses sort of dominate the landscape, and then eventually the trees or the normal eucalyptus trees in the area will sort of dominate the landscape. Problem that we're having in some areas of New South Wales, particularly in the North Coast, is that water regrowth is taking longer than what's being typically found to be the case to be replaced by the natural eucalyptus regeneration. So that is an issue in terms of the ecological succession that should be taking place in those areas. So potentially presents an opportunity there to use or to harvest the water and potentially use for something like biochar. And what is biochar? I know that my colleague Lucas presented, I think it was the last webinar on biochar, so I don't need to talk too much about it, but just to give a one slide summary. So biochar is a product of pyrolysis process, which is basically controlled heat scenario there of a biomass feedstock, which could be plant or animal material, high temperatures in an environment of low oxygen. And that process generates typically three products: the char product, syngas, and bio oil. And the biochar then can be produced either in large static facilities, I suppose, in strategic sort of locations, or in the case of the topic of our talk today is the opportunities around mobile units as well. Biochar, one of the attractive things about biochar is that it's one of the recognized mechanisms for carbon dioxide removal, so as a climate mitigation strategy, and attracts a carbon revenue from that. And it has a variety of applications, not typically the traditional applications into soil, but also other emerging opportunities. There's a lot of opportunity around animal feed to reduce methane emissions, also in terms of adding to road aggregate products, or construction materials, or in the manufacture of steel, replacing coal, in which case the product is called biocarbon. Now to the main topic of this talk, the mobile biochar torrefaction unit. So it's a prototype that we've been developing. So we've commissioned someone from Glenina's, John Winter, who is a farmer and an engineer, so he's the owner of a business called Round Hill Engineering. So he's been working on this concept for a while, and John has recently finished commissioning of that particular unit. The idea is that it's a prototype unit for demonstration purposes at this point in time, so it's transportable on a flat top truck. Its output in terms of biochar generation, typically, envisaging around 100 to 200 kilograms of biochar an hour, so obviously not a commercial scale plant, but enough to demonstrate the concept, and higher quantities of output if you're talking about a torrefied product only. And when I talk about torrefaction, it really is when you basically take the product from a green product halfway through to biochar. So you cook it halfway basically to get it to a torrefied product, which basically can be transported in the case of weeds without a need to worry about spreading the weed into the landscape. So this unit can do both. In terms of the logistics of how to feed the unit, there's a hopper. So basically the material needs to be chipped first and then fed into the hopper via an excavator. And here's a diagram of engineering diagram of the unit, and you can see the picture here on the top left-hand corner. Basically, the biomass fed into the hopper via the feed auger here, and then it goes through the processes of heating. It's basically self-heating in the sense that the biomass that is burned produces a syngas, and the syngas is then used to dry the biomass itself. It goes through a series of processes where it then eventually it leaves the unit as a torrefied biomass product or a biochar product. And here is a little video that John made for us. The sound's a little bit soft, so I'd encourage you to crank up your volume if you can, but it gives you a bit of a sense about the scale and the different bits and pieces. So I'm just going to play this for you now. Constructed a BPI here we can see where the biomass is divided into the action vessel. We have a startup burner that runs continuously here that provides the heat, the initial heat for the start of the reaction. From there on in, it's self-sustaining. The syngas that is evolved from the biomass itself. Combustion air is continuously provided into the vessel. The heat from that is then transferred into the biomass itself, which travels along to the reactor to set the rest of its time and dropping out the end. Target temperature in here is 280 degrees to 300 degrees, which is the point where cellulose decomposes to carbon and syngas, whereas the lignin remains intact. The main product for that here is an example of macadamia shells that have been purified, so that's what it looks like going in. And then on the way out, it essentially the remaining carbon and like so whatever shape goes in comes back out. This is a simple what's called non-recovery unit, so all of the syngas generated here is used for its own heat source, so there's no external heat source required, just combustion air once it's up to temperature. The steam control unit, and then temperatures are recorded and controlled within this cabinet. So the system is a very simple process. Okay, so I hope that's given you a bit of a sense about the unit itself. So where to next with the development? So we'll be taking to the test at a state forest at Kyogo, Burby State Forest, where basically the interest there is that we've got a situation where there was a blackbutt plantation that failed, so a lot of those trees died, and there's also quite a bit of a problem with a Lantana infestation there. So there's an opportunity for us to produce the biochar both from the blackbutt. That's the dead blackbutt trees and the Lantana, and then test properties of the two types of biochar that we produced. And then State Forest Forest Corporation New South Wales is going to replant the area. So we start again, and we're going to be basically putting the biochar that we produce back into the soil with a mix of fertilizers to encourage the best growth possible for the new plantation. So that's the prototype. Sorry, that's the prototype scale we're talking about, and then hopefully that will lead into interest around the development of commercial scale unit. And from a commercial scale unit perspective, we're really talking about a much higher throughput plant design and about 3 to 5 tons an hour. The biochar then produced can be applied to the soil, which obviously would be eligible to attract carbon revenue. But carbon is not the only really benefit here. Obviously, if you're talking about, for instance, a situation where you're using existing weed as a feedstock, then obviously having the biochar as a market opportunity provides an incentive for the landholder to remove that weed and actually earn some money from it. And also it provides an opportunity to restore that land to what that was previously infested with the weed, to be able to restore it to its natural sort of environment. And by doing so, also improve the carbon outcome overall, because you're going to be having natural vegetation, trees, as opposed to weeds on that same patch of land. And obviously having a much improved social license overall. When we talk about carbon revenue, we're talking about primarily this scheme called the Pure Earth scheme, which is based in Finland. So that's an international offset program which has biochar as one of its opportunities for carbon removal. So they generate CORCs, which are CO2 removal certificates. Basically, there's a methodology in place. You can see the documents here, one around the market for biochar, another one with the actual methodology for CO2 removal using biochar. One of the requirements is that obviously the biomass has to be sustainable, can't be from land clearing, for instance. If it's applied into the soil, there are some stringent requirements about storage. It has to be demonstrable 200 plus years of storage. But obviously, soil is only one of the applications that we talked about before. There are many other applications for biochar. If you want to find out a bit more about this particular program, here's the website. So I guess from a New South Wales perspective, we see this as an opportunity. I hope I've talked about the different types of biomass and the range of options that we could present themselves for landholders. And I guess there's an opportunity here to consider a network of mobile units of varying sizes, which obviously would be geared towards the type of feedstock or the type of land that you would be applied into. So if you have areas which will easy access and large roads, etc., then obviously they lend themselves more to larger units. But if you've got trickier areas for access, then you're probably considering smaller units in that case. So, and as I said, the opportunity here around carbon credits, the Pure Earth credits have up until recently been trading at $150 a ton of CO2, so that's quite attractive. And also these other benefits around ecosystem restoration, about reducing fire risk, which all can obviously add to that overall attractiveness of the concept. So because you're not actually, if the business model was to produce the biochar on site and then actually apply the biochar on site as well, then there would be no transport requirements. So, and transport is typically what drives costs for biomass related projects. So in this case, if there was no transport requirements, then the payback periods for those units would be very, very quick. So in summary, many biomass options in New South Wales, as we just talked about, transport and aggregation costs are quite challenging for traditional markets. The mobile unit provides landholders an opportunity for dealing with the issue on site. We are currently in the process of running demonstrations with the prototype, hopefully successfully leading then into interest around development of commercial scale units. And then, that being driven by carbon revenue and other benefits that you can achieve in the landscape. So that's in a nutshell what I had to say.
Fantastic. So Fabiano, I think we have teed up maybe doing a demonstration in like Q1, Q2 next year. Is that right? Yep.
Correct. So that's the Kyogo State Forest work. So
Awesome.
we will be having an open day or a field day there as a demonstration. So obviously we will be making that information available as soon as we can in terms of when that's going to happen.
Absolutely.
Hopefully the weather will be kind to us and we'll be able to get there. But yeah, we'll see.
Okay, great. So I'll just let everyone know when that's happening so that they can put it in their diaries. But on that note, I know you have other commitments this afternoon and I'm going to let you go. But Fabiano, thank you so much for making the time.
Thank you, Camilla, and everyone else.
Amazing, amazing presentation.
I'm
Thank
happy
you.
to be in touch with anyone, if, after this. So, yeah.
Great. This is the last one for 2025. Next year's series will be more farmer focused. But yes, that's it. Thank you very much. Have a happy and safe Christmas to you all.
Thanks, everyone. See you guys.